Okay, here we go. So in real life problems, you want to find the number of possibilities when you're dealing with statistics. So for example, say if you own a small deli and you offer 4 types of meat, ham, turkey, roast beef, and pastrami, and you offer 3 types of bread, white, wheat, and rye. How many different choices could your customers have to choose a sandwich? Okay, so we're going to make first a tree diagram to see how many choices they would have. Alright, so let's start with naming all the types of meat. Starting with ham. What's the next one? Turkey.
Roast beef.
And pastrami.
It's like pepper.
Kinda. Alright, so to make a tree diagram, we are just going to make branches from each of these 4 categories to see how many choices we have for each type of meat. Okay, so with ham, you could get what? Ham on white, wheat, or rye. And how many different choices is that? 3. So I'm going to put equals 3 in total. Alright, for turkey, same thing, right? I'll shorten it up. So white, wheat, or rye. That's how many choices? 3. Roast beef, again, that can be on white, wheat, or rye. Another 3 choices. And same thing with pastrami. I'll give y'all time to copy that down. So if we add up all our different choices, how many different combinations could they have in total? 12. Good. Thank you, Eric. Your notes are in the blue folder, and they have your name on them. Okay. Any ideas of how we could have made this easier?
Multiply.
Multiply what?
3 times 4.
Okay, where did you get the 3 from?
The bread.
Good. There's 3 different types of bread, right? How many types of meat were there?
4.
4. So you could have just done 4 times 3, right? Alright, so another way to count the number of possible sandwiches is to use, and this is what we call the fundamental counting principle. And it says because you have 4 choices for meat and 3 choices for bread, the total number of choices is 4 times 3. And that's called, again, the fundamental counting principle. And we're going to use the fundamental counting principle for the next few problems to see what all our options are, how many options we have. Alright. Diego, if you'll read example 1 for me.
Police use photographs of various facial features to help witnesses identify suspect. One basic identification kit contains 120 hairless, 99 eyes and eyebrows, 89 noses, 86 mouths, and 74 chins and cheeks. Source: Reader's Digest. How in the world?
So this is a true statement. Okay. Alright, read part A for me.
The developer of the identification kit claims that it can produce billions of different faces. Is this claim correct?
Alright, so we're going to figure out all the different possible choices. Okay, how many faces they can come up with. And we're going to see if this claim is correct, that it can produce billions of different faces. So how would we find all our possible choices? Multiply all of these together. Go ahead and do it on your own. And I'll call on one person for the answer. And you might not be able to read it from your calculator, so when I call on you, just say what the answer would be. Just read out the different numbers. Go ahead, Guy.
Yes, it's 6, 7, 2, 8, 7, 8, 4, 4, 8, 0.
Good. Alright, now to see if this is millions, billions, and so on. Let's go ahead and place our commas. So we place them every what? 3. Alright, so this is talking about what?
Is it
Hundreds, right?
100?
Thousands. What's the next one? Millions, this one is. So, if it says that it can produce billions of faces, is this claim correct? Yes. More than 6 billion, right? So yes, that claim is correct. And then for part B, it says a witness can clearly remember the hairline and the eyes and eyebrows of a suspect. How many different faces can be produced with this information? Alright, so let's go back at the features that it does. Alright, does she remember its hairline, or the person's hairline?
Yes.
Alright, so do we have to have 120 choices?
Oh.
How many choices will we have? 1 if she remembers it, right? So let's do 1 times. What about eyes and eyebrows?
99.
One.
Good, because it said she remembers the eyes and eyebrows too. Does she remember the nose?
No.
So it'd be times,
89.
and then the mouth she doesn't remember, so it'd be times 86 and 74. So go ahead and come up with how many different faces she would have to choose out of if she could remember those 2 aspects. Go ahead, Austin.
I got 566,396.
Good. Isn't that crazy?
Yeah.
If she remembers 2 facial features, she would still have to choose out of that many, or it would still come up with that many faces.
Is this like a real thing?
Alright, any questions about example 1? Alright, Haley, if you'll read example 2 for me.
Source, New York State Department of Motor Vehicles.
Okay, go ahead and read part A.
How many different license plates are possible in digits and letters can be repeated?
Alright, so it says how many digits are in the license plate? 3. Let's go ahead and make 3 blanks, like we're making a license plate. And how many letters? Alright, so let's make 3 more blanks. So this is a license plate, and we're going to figure out how many different options they have. Alright, 3 digits that could go into a license plate. Name them out. So let's start with the smallest. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So that's 10. Why couldn't 10 be one of them?
Got 2 digits now?
That's 2 digits. Good. Alright, can a license plate start with 0?
No, it starts with
Are you sure?
Let's start with where you're going.
Are you sure for every state none of them can start with 0?
Yes. One of them.
Alright, let's just assume that one of them could start with 0. We don't really know. So how many options do we have for a digit? 10. Okay, so we'll put a 10 in this blank.
No, look it up.
Nope. Alright, and it says that it could be repeated. So how many options would we have for the next one if it's a digit? 10, same thing. And the next one? 10. Alright, then it says 3 of them are going to be letters. How many different letters could we put in one spot? 26. Good. There's 26 letters of the alphabet, right? Okay. So you'd have 26, 26, 26. So to find all the different license plates that would be possible, we do what? Multiply.
That's a big old number.
Alright, so Heidi, if you'll tell me that number. Jabari. Did everybody get this one? This number? Good.
For some reason I got that.
You probably typed in something wrong. So that's how many different license plate would be possible in New York.
Yeah, there we go. I don't know what I did wrong.
Questions about that one?
Did you have to use 10 and 26?
Yes, because 10 represents how many different numbers you could have, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then the 26 represents how many letters there could be, because they could be repeated. But now let's talk about if they couldn't be repeated, okay? So let's make our license plate blanks. So let's say we have 10 options right here for numbers, correct? It would go to 9 because think about if we put a 0 right here, right? And we couldn't use 0 again, correct? So how many options would there be? 9, one less. So what do you think the next one's going to be?
8.
Good. And then with letters, it'll be
26, 25, 24.
good. Go ahead and find the possibilities. I'll call on one person. All right, Levi, what'd you get?
1, 1, 2, 3, 2, 0, 0, 0.
Very good. See how the possibilities cut down when you do that?
Yeah.
Are there any questions about that one? Does that make sense? Okay. All right. Guy, if you'll read example 3 for me.
A popular brand of pen is available in 3 colors: red, blue, and green, and 4 writing sets: bold, medium, fine, or micro. How many different choices of pens do you have for this brand?
All right, you're doing this one on your own, and then I'll call on one person. If you can give me the correct answer, you can get a piece of candy. All right, Diego, what'd you get? Good, because you would do how many different colors? Times. So you could have 12 different choices of pens. Here you go. Any questions? We're good with fundamental counting principle. All right, flip it over. Mackie, if you'll read that for me, that first sentence.
You need to arrange 7 of your favorite books along the small shelf. How many ways can you arrange the books, assuming order matters to you?
All right, so how do you think we would do this one?
Would you do like 7 different?
All right, so here's our 7 different books. 1, 2, 3, 4, 5, 6, 7. Right here, how many different books could you put on the shelf if no other books are on there? 7, right? You'd have 7 options. All right, now say that one book is on the shelf. The next book, how many different options could you have? Good. The next one? Next?
4, 3, 2, 1.
Good. Go ahead and find out how many different options you would have. And y'all can say it out loud whenever you get it.
5,040.
Good. There's 5,040 different possibilities. All right, the product that we just did in this one, first of all, any questions? Okay, the product that in this example is given a special name and a symbol, and it's called 7 factorial, and it would be written as 7 with an exclamation mark. So this right here would be 7 factorial, and to simplify it, you would see 7 exclamation mark. So therefore, if n is a positive integer, and let's just review, what is an integer? What now? What kind of number? Positive. It already said positive, right? A whole number. Good. Right above here, whole number, so y'all remember. Positive integer is a positive whole number. So give me some examples.
1, 2, 3.
Okay, good. All right, and the notation n factorial, and red n factorial, is the product of all positive integers from n down through 1. So, for example, n factorial would be n times n minus 1 times n minus 2 times n minus 3. And you can see how this example works in. Let's replace this n factorial with 7 factorial on top. So this would be, instead of n, we could put what? 7 times 7 minus 1, which is what? Times 7 minus 2, which is? Minus 2, not times 2. Good. And then times 7 minus 3, which is 4. And so on until you get to 7 minus 6. And we can see that's what we calculated up here, right? 7 times 6 times 5 times 4 times 3 times 2 times 1. That's called 7 factorial. So how would you find 5 factorial? Tell me what that would be. 5 times 4 times 3 times 2 times 1. Good. 3 factorial would be 3 times 2 times 1. Good. 0 factorial by definition is 1. And you'll just need to memorize that. Anytime you see 0 factorial, that's just going to be 1. Alright, so right here we're going to find a few factorials together. So for this one, 4 factorial would be what?
3 times 2 times 1.
Alright, go ahead and find that on your own. And you can say it out loud whenever you get it.
24.
Good. Raise your hand if you have a TI-83 or a TI-84. Raise your hand if you have a TI-83 or a TI-84.
Oh, I have a TI-59.
No.
I'm a TI-30.
Alright, if you do, let me show you a cool button on here, okay? Just for a second. Alright, say if we just wanted to do 4 factorial like we did, please follow along. Press 4. Okay? Then press the math button. There's a math key right here. And see where it says PRB? Go over to PRB. And see where it has that exclamation mark? That's a factorial, so you can go down to it, hit enter, and it'll give you the factorial. You don't even have to calculate it. Which is really useful if you get to like 13 factorial. For 13 factorial, you'd have to do 13 times 12 times 11 times 10 times 9, all that, right? With this, you can just hit 13 math, go over factorial, and it'll give you the answer instead of you having to type it out, okay? Any questions about that? Yeah.
Isn't it different on the PROV?
Okay. Well, you found the key, right? Okay. Alright, moving on. So for 8 factorial, go ahead and find that one on your own. Go ahead and find it on your own, and then tell me what you get. Hold on one second, also. Do you have a question, Alonda, or you want to answer? Okay. What you got for 8 factorial? Huh? You, Alonda.
Oh, I got 40,000.
Good. Did everybody else get that?
Yeah.
Try it again. Yes. Yeah, 8 times 7 times 5, or 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You need this? Oh.
Be quiet.
Okay.
Okay, now I'm good.
So what would 1 factorial be, everybody? 1. Alright, now let's look at when we divide factorials. Looks complicated, but it's really pretty easy, okay? Yes. Okay. Let's go ahead and write out 4 factorial over 2 factorial. So what would 4 factorial be? 4 times 3 times 2 times 1, right? What would 2 factorial be? 2 times 1. Notice how 2 times 1 is on top and bottom? We can cancel those out. Because 2 divided by 2 is going to be what? And 1 divided by 1? So now all we're left with is 4 times 3, correct? Which is what? 12. Good. If you have your TI-83 or 84, you can divide factorials. So let me show you right quick. Zoom out. So you would do 4, go over to math, go all the way over to PRB, and, oops, I pressed the wrong button, sorry. Math, PRB, and then divided by 2, PRB, 4, and it'll give you the same thing. Okay. All right. Go ahead and try 5 and 6 on your own, and then we'll go over them in just a second. find your own? Alright. Anybody want to do 5? I don't have any more candy, but go ahead, Austin.
I got 56.
Very good. Any questions about that one?
No.
Alright, Darius, what'd you get for number 6?
7.
Good. Any questions about that one? Yeah, I can. Alright, so for 8 factorial, tell me how to write 8 factorial.
8 times 7 times 6 times 5 times 4 times 3 times 2 times 1.
Good. All over.
6 times 5 times 4 times 3 times 2 times 1.
Good. And see how all these numbers will cancel out? The 6, the 5, the 4, the 3, the 2, the 1. Right? So what would 8 times 7 be? 56.
So if we multiply all those together and just divide it over and come out with the sum?
Yeah, you would just have to multiply all these equal divided by parentheses times all those. Alright, so this one would be 10 times 9 times 8, 7, 6.
5 times 4 times 3 times 2 times 1.
Good. All over.
7 times 6 times 5.
Alright, so all these cancel out, right?
Oh,
So you would only multiply what?
9 times 9.
Good. 10 times 9 times 8. Any questions about that one?
Yeah.
Alright. Caitlin, if you'll read 7 for me.
12 skiers are competing in the final round of the Olympic freestyle skiing and racing competition. And how many different ways can the skiers finish the competition? Assume there are no times.
Alright, so if there are 12 skiers, and how many different ways can they finish? Can 2 skiers get first place?
Yes.
No.
They can tie.
Says there's no ties.
So if they keep tying, they're going to keep.
Alright, so let's draw 12 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many different options could we have for first place?
1,
12, right?
12.
So say if one person gets first place, how many different options could we have for second place? 11. Y'all see where this is going? So what are we asking to find really? 12, what? What's it called? Factorial. Good. Alright, go ahead and calculate it on your own. And I'll give you time because I know this one's a little bigger.
Oh, that's a big number.
Go ahead, Austin.
479,001,600.
Good. So that's how many different options we could have.
If you had that much money, you would move.
We're not talking about money.
No, I'm just saying, what if you had that much money?
She would you buy it later?
She would be teaching.
Yes, I would. Alright, do number 8 on your own.
You'd still be teaching if you had all of them?
Would you give me some?
Focus, focus, focus.
You could buy an island. No one chips that.
Oh, I do have more candy.
Oh, no, that one's for me. Just one.
Y'all must want homework tonight. Focus.
This one.
I'm just playing. I'm just playing.
This one.
Alright, what'd you get? Very good. 120. And it's because that we found 5 what? What's it called?
5 exclamation mark.
What's it called? Factorial. Good. 5 times 4 times 3 times 2. Do we have to put a 1 on the end, really? No.
You know.
Alright, questions about factorials? Yes,
Does it not go all the way to 1?
it does, but anything times 1 is just going to be what? Good. So we don't have to put it. Just like we don't have to put 0, right? Alonde, please turn around. Just like we don't have to put 0 because 0 factorial is just 1. Alright, give me 1 second. Yeah, let's go ahead and do these. Actually, no. What I'm going to let you do now is if you flip to the very back You'll see your homework